Welcome to today's class. Today we are going to discuss ray diagrams showing image formation. In the previous class we already discussed the ray diagrams which shows the nature of reflected rays corresponding to various incident rays. Now, image formation. When will an image be formed? And different types of image also will be formed. So that activity we will be discussing later. So we will be discussing how the real images and virtual images are formed. So generally there are two types of images, real image and virtual image. There are two types of images, real image and virtual image. Real image means the image is formed really, or it can be focused on a screen. You can focus real images on a screen, whereas virtual images cannot be focused on a screen. Okay, so this is the main difference between real image and virtual image. The image which can be focused on a screen are called real images, and the images which cannot be focused on a screen are called as virtual image. I think you remember the image formed by a plane mirror is a virtual image. Now, in the case of concave mirror, so yesterday we discussed the nature of reflected rays. So the thing is this, if the reflected rays actually meet at a point, different types of reflected rays, if they meet or intersect at a point, real image will be formed. So we are going to discuss the image formation in the case of concave mirror. There are many diagrams to be discussed. Altogether 6 diagrams are there for a concave mirror. So one by one we will discuss. It corresponds to different object positions. Depending on different object positions, the corresponding ray diagram will be different. 2-3 ray diagrams we will discuss in today's session. The rest we will do in the next class. Okay, so first one, it corresponds to the object position. That is when the object is kept at infinity. When the object is kept at infinity, where lies the image? What do you mean by object at infinity? When the object is at far distance from the mirror. That means the distance of that object cannot be compared. Its distance cannot be compared with the distance like focal length or radius of curvature. On the principal axis, we cannot mark its position. So such distances we call as infinite distance. So objects at far distance from the mirror where the image will be formed. That's what we are going to draw. So in the case of concave mirror, we are drawing concave mirror. So object is at infinity. So from the object, the rays coming. So first step is to draw concave mirror, then principal axis, mark the points P, F and C. And take care that F should be at the midpoint of PC. F should be the midpoint of PC. In that way you have to draw, because we already said R is equal to 2F. We already mentioned radius of curvature is twice the focal length. Okay, so this way we have to start with. Now what type of rays we can draw? Actually we can draw any of the 4 incident rays what we discussed the previous class, but here no, since the object is at infinity, from the object at infinity, incident rays are coming parallel to each other. The rays are parallel to each other, and here we assume the rays are parallel to the principal axis also. So from the object at infinity, we assume 2 rays, incident rays, which are parallel to the principal axis and parallel to each other. Okay, so 2 incident rays which are parallel to each other and parallel to the principal axis we have drawn. So if the incident ray is parallel to the principal axis, what about the reflected ray? The reflected ray should pass through the focus. So reflected ray passes through the focus. So that's what we have drawn. So where lies the image? Because 2 reflected rays intersect at the point F. At the focus, the two reflected rays intersect. See, where the reflected rays intersect, at that point we'll have the image. So in this case, where lies the image? At the focus, the image is formed. And you can see the two reflected rays, they really intersect. They are intersecting really. So that type of image will be, the nature of image formed will be real. Okay, the nature of image formed will be real, and they intersect at a very small point. You cannot distinguish the top and bottom of the object, and so we can say that very small image is formed. Point sized image is formed at the focus, which is real, and it will be inverted also. Okay, when we do experimentally, no, that means when you keep the concave mirror in front of an object at far distance, and when you get the image on the screen, you will be getting inverted images. So we can say that the image formed is inverted. So there are some characteristics of the image which you can write from here. Okay, so first characteristic is the image formed is inverted, and it is real. It is a real image which is formed. So real and inverted, and it is formed at focus. Where the image is formed, it is formed at focus. And the thing is this, the size of the image is point sized. So these four characteristics we can write about the image formed when the object lies at infinity. So which are the characteristics? The image is formed at the focus. And what are the characteristics of the image formed? It is real, inverted, and the size of the image is very, very small. It is point sized image. Hope you followed. When the object is at infinity, image is at focus. Okay, now we move on to the second position, that is when. So in the case of a concave mirror at infinity, we already discussed. Now on the principal axis itself, we will discuss the object positions. So next case is beyond C. Beyond C. So we will draw the diagram as we have drawn in the previous case. So second case when the object lies beyond C. The object position is beyond C. So we'll draw the diagram. So this is concave mirror. As we have drawn earlier, draw principal axis, focus, and center of curvature. And beyond C, you have to show an object. So this is how you show an object. You draw a vertical line on the principal axis and put an arrow mark. That is your object. So this is the object. Okay. Now what we are going to draw is the image. So the thing is this, I have already told you, where will you get the image? At the point of intersection of reflected rays, you will be getting the image. So you should draw two incident rays, minimum two incident rays you have to draw from the head of the object. This is the head of the object. From the head of the object, two incident rays you have to draw. That two incident rays can be any of the four which we discussed in the previous class. We discussed four types of incident rays. First one parallel to principal axis, second one passing through center of curvature, third one passing through focus, and fourth one incident at the pole. So any of the four, any two from the four you can select and draw from the head. From the head itself you have to draw at least or minimum two incident rays. So we will draw. So first one is as usual, that is incident ray which is parallel to the principal axis, so that after reflection the reflected ray will pass through the focus. So first step is over. Now we have to draw one more incident ray. So we can select the second one itself, that is a ray which is passing through the center of curvature. A ray which passes through the center of curvature, it retraces the path. So when we draw a ray which passes through the center of curvature, so this is the direction of incident ray. You know, the reflected ray retraces the path. So you can put the arrow mark in the opposite direction. So the reflected rays, the two reflected rays, they intersect at this point. So that is the point where we get the image of this head. So this head comes here. Okay, so this is the line where this the bottom of the object is there, no, lower part of the object. So since this ray, that means it gets reflected in the same direction. So here itself you will get this portion. So the thing is this, the image obtained will be an inverted image like this. Okay, so where lies the image between C and F? We kept the object behind or beyond C, and we are getting the image between C and F. Between the center of curvature and the principal focus, we are getting the image. So we can write the position of the image is between C and F, and the image formed is, again, it is real. No doubt it is real because the reflected rays, they really intersect, and the image formed is inverted also. The image formed is inverted. So image is formed between C and F, and the image formed is real and inverted. And what we have seen is, this is, see the size you can compare, compared to the object, this image is small in size. So the image formed is small in size. So these are the three things we can say about the image formed when the object is kept beyond C. The image is formed between C and F. The image formed is real and inverted, and the image formed is small in size. So that is the case. Second case, when the object lies beyond C. Now one more case we will discuss today, lies at C. So object is kept at C. So concave mirror we are drawing, and principal axis, this is the point P, then F, here comes C. Now at C we are keeping the object. So how to start drawing? As I said earlier, minimum 2 incident rays you have to draw from the head of the object. So first ray, always we are drawing the first ray to be parallel to the principal axis. That is the easiest one. Okay, now the second ray we cannot choose through C. So we'll choose the one through F. So through F. So when the incident ray is passing through focus, the reflected ray will be parallel to the principal axis. So you have to draw the reflected ray to be parallel to the principal axis. Okay, so you are getting the image also at C. Did you see? So this is the point of intersection. At the point of intersection, you will get the image. So where lies that image? You see, where lies the image? Image also is formed at C. So image is formed at C. Now you can compare the size. The two are having the same size. So both the object and image are of same size. And here also the image formed is real and inverted. So what all things we can write? The image also lies at C. When the object is at C, image also is at C, and the image formed is real and inverted. Real and inverted image is formed, and the image is of same size as that of the object. The image formed is of same size as that of the object. So these 3 points we can say about the image formed. So today we discussed 3 cases, that is when the object lies at infinity, image was formed at F, and the image formed was very small in size, of course real and inverted. When the object was kept beyond C, okay, image was lying between C and F, and the image was smaller in size but not point sized, smaller in size, again real inverted, and it was formed between C and F. Okay, so from F it is moving. So object is coming close, image is moving away. You can compare. Now when the object is kept at C, image also is formed at C, and the image is of the same size as that of the object. Now 3 more cases are there for concave mirror that we will be doing in the next class. Only this much for today. Thank you.